I think we're on the wrong page. But this is A&P1 Lecture Test 2, Video 6 with Dr. Jones. We are on page 10 of the note set, and apparently on the wrong page. We need the fluid connective tissues. Here we go. Okay, try again. Okay, so there are two kinds of fluid connective tissues. They are blood and lymph. So for blood, it has a watery matrix called plasma. Plasma is the part you can donate. You cannot sell body parts, obviously. So you are getting paid, you're getting reimbursed for your time, and you're giving the plasma, but being paid for your time. See how that works. And the solid bits are the formed elements. There are three main types of formed elements. The erythrocytes are the red blood cells. There are 0.9% of the formed elements, and therefore about half of the blood. The blood is ish 50% plasma and ish 50% formed elements. That makes it ish 50% red blood cells, and that's why red blood cells are red, because that's why the blood is red, because it's half red-ish red blood cells. It's a little different for every person. We'll get more into that next semester. You also have, at less than 1% of the formed elements, the leukocytes, which are the white blood cells, and less than that are the platelets. And the red blood cells function in gas exchange to carry oxygen and carbon dioxide. The white blood cells function in immunity. They fight infection, and in different ways, but that's next semester. And the platelets function in coagulation, which is blood clotting. So there are three different types of liquid in the body. There's the plasma of blood, and that's found in the blood vessels. There is arteries and veins. There is the lymph in the lymph vessels, and then the interstitial fluid or extracellular fluid in between the cells. So there's a cycle. The blood at the capillaries, and the capillaries are the smallest of the blood vessels. The blood pressure is higher than the pressure of the extracellular fluid or interstitial fluid. And so the plasma part of the blood gets squished out into the extracellular spaces to become interstitial fluid or extracellular fluid. And then that enters the lymph vessels, and the lymph vessels do have lymphocytes, which are a type of white blood cell, and the lymph vessels also have lymph nodes that filter the fluids, and then they get dumped right back into the bloodstream, right up here on both sides. Did I add the picture for that? No, I think I added that to the 2402. So next semester, we will talk about that briefly again. So the three liquids, though, just the liquid parts: the plasma of the blood, the lymph of the lymph vessels, and the interstitial fluid, which is in between the cells. Okay. And it has a water cycle, just like our water cycle, you know, like rain, evaporation, rain, evaporation. Okay. Cartilage. The matrix of cartilage is a firm gel. I need to go back, don't I? No, I did that. Yeah? No, we had that conversation. Okay. Matrix of cartilage is a firm gel. So unlike the connective tissues proper, where it was syrupy, this is more like jigglers, maybe harder than jigglers. Mature cartilage cells are called chondrocytes, in spaces called lacunae, and I'm sure we've had this conversation in lab. And cartilage has a perichondrium, which surrounds it, with an outer fibrous layer and an inner cellular layer. And we will hear that again, an outer fibrous layer and an inner cellular layer. And so let's collect all of the places we find an outer fibrous layer and an inner cellular layer. Next question. Excuse me, some in my throat. Okay, so name that tissue. You got it. This is hyaline cartilage. This picture is terrible. That's a terrible picture of hyaline cartilage. And the functions, they are tough but somewhat flexible. It provides support, reduces friction. Found at the joints. It's found between the ribs and the sternum, lines the synovial joints. Also some of the nasal cartilages, respiratory tract, yada yada. I think my daughter's phone is ringing. Elastic cartilage, which we also discussed in lab, is just exactly like hyaline cartilage, except with all these blue elastic fibers. And it's stretchier because elastic is stretchy. So it changes shape without damage. You find it places like the external ear, the epiglottis, which is the part that closes over your windpipe to keep your food and drink out when you swallow, and also the auditory canal, which is in here. What's that? Rose. There you go. This is fibrocartilage. It resists, I don't know why it does that. It resists compression and limits movement. It absorbs shocks. It is found in the intervertebral discs, the pubic symphysis, and there's also some fibrocartilage. And you can do this one word, fibrocartilage, or two words, fibrous cartilage. And there are fibrocartilaginous joints, like these intervertebral discs are only fibrocartilage. But then also some of the synovial joints, like the shoulder, the hip, and the knee, do have fibrocartilage pads. So found in several places. All right, up through adolescence, going backwards because I thought I'd fixed this already. Appositional growth. Cartilage undergoes both interstitial and appositional growth, but in an adult, cartilage does not grow, rarely repairs, and covers injuries with a dense fibrous patch. True. So appositional growth helps it grow in diameter because it adds more cartilage around the outside. Just inside the cellular layer of the perichondrium builds matrix, and that makes the diameter get bigger. Okay. And then the interstitial growth grows new matrix inside, and that helps keep the cartilage. Cartilage doesn't repair very well, but it can build new matrix. So it's one of those things. So because this hyaline cartilage is supposed to line all of the joints, but sometimes it wears down, and often wears away. So do you know anyone whose knees are bone on bone? Yeah, hurts like Hades. And what happens is when the cartilage on the end of one bone gets damaged, it doesn't heal well, and it makes a dense, scratchy, fibrous patch, which then scratches the cartilage on the facing bone, which doesn't heal very well. And when it does heal, it makes a scratchy, dense, fibrous patch, And then they like two Brillo pads wear each other down until you're bone on bone, and then you get a brand new knee, and it works great. Most of the people I've known, almost all of the people I've known who have gotten a knee replaced, the only thing they said afterwards was they wish they had done it sooner. So much sooner. So, all right, so that was page 10. Let's see, I actually put the timer on this time. That was 11 minutes. So let's go ahead and finish our cartilage. Well, let's talk about bones, and then talk about cartilage versus bones, and maybe we'll finish the tissue membranes. Yeah, we might get 2 pages in this video. We'll see what happens. Okay, so there are 3 types of cartilage, and then bone. Bone is called osseous tissue. 2/3 of the matrix is calcium salts. Calcium salts are hard but brittle. Imagine like a quartz crystal. It's hard, but if you hit it with a hammer, it's going to shatter. Okay. 1/3 of the bone matrix is collagen fibers. They are strong but flexible. So this would be like wet noodles, but like you can't smush them. Okay. Mature bone cells are osteocytes in spaces called lacunae. Now in the cartilage, the lacunae, which is the space, is much bigger than the chondrocyte, and you can see the space between the edge of the lacuna and the chondrocyte. In bone, okay, more, there we go. The osteocyte is the size of the lacuna. The lacuna, the space that the osteocyte is in, is only as big as the cell. It's only as big as it absolutely has to be. It'd be like if you had Jello with grapes in it, and then you cut, I don't know if cuts Jello, just like dig in. My kids, but you cut, they do cut jigglers. I don't know if we've made jigglers with grapes. So you cut through your Jello, and you cut through the middle of a grape, and then you can pull that grape out. Now, once you've pulled the grape out, then you can see the space where the grape was. That's how osteocytes in lacunae are. You would have to pull the osteocyte out to see the space that it's in, because the space is the size of the cell. So that's why. So the osteocytes in lacunae, I was talking about something. Oh, mature bone cells are called osteocytes in spaces called lacunae. Yeah, osteocytes in lacunae. And what are canaliculi? Ooh, and we'll have this term again next semester, but canaliculi means little canal. Little canal. And they are slender cytoplasmic extensions of the osteocytes. So they're these things. Also here you can see them. They're these little lines. My pen is about 10 times too thick to really show them, but they're these little lines that you see. And they connect one osteocyte to the next osteocyte, and they exchange nutrients. Because where are your blood vessels? In the bone, in the central canals. And so how is the oxygen and nutrients from this artery supposed to get to these osteocytes? It travels through the canaliculi from osteocyte to osteocyte. So that's how. So sometimes when they talk about canaliculi, they talk about the hole in the bone that the cytoplasmic extension goes through. It's just like a pipe through a wall. Sometimes they talk about the hole in the wall for the pipe, and sometimes they talk about the pipe carrying stuff. It's kind of the same, but they talk about it differently. So, and the canaliculi do exchange materials. So they take nutrients out to all the cells and the wastes back to the veins. Bone has a periosteum with an, outer fibrous layer and an intercellular layer. Where have we heard that before? Oh, the perichondrium. The perichondrium had an outer fibrous layer and an intercellular layer. Now we have the periosteum with an outer fibrous layer and an intercellular layer. I wonder if we'll have a third example. Keep your eyes out for that. So that sounds like a test question too. Unlike cartilage, bone only goes appositional growth, which stops at skeletal maturity. Bones can respond to stresses. Can bones respond to stresses and complete repairs? Yes, they undergo extensive remodeling. So more you exercise, you can make your bones thicker and stronger and sturdier and less likely to break. But with inactivity, bones become thin and brittle, and it only takes a few weeks of inactivity to lose like a third of your bone mass, which is terrifying. When I was a kid, they used to put everybody on bed rest for everything. Like, oh, your back hurts, you stubbed your left toe, go on bed rest for a month. And now they don't put you on bed rest for anything unless like the baby is actively falling out of your body despite the cerclages. So very, very rarely now do they prescribe bed rest unless they absolutely have to, because not moving does damage to your body. We just don't work well that way. All right, so let's compare cartilage and bone. I can't read other people's charts, so I make a blank version of my own and I can fill in a chart and then it makes sense to me, but I can't like read this stuff in the book. It's just like I gloss over in about 0.02 seconds. So that's why I've given you blank versions of so many of the useful charts in the book, because I can't read them. I have to fill it in for myself in order to process the material in it. So if you can read this, go for it and like process. And yeah, I can't focus that long on something that boring. So we'll write it down. The more interactive you are with the material, the better it sticks in your head. So saying something out loud is more interactive than hearing it. Writing it is more interactive than reading it. Even just highlighting it while you're writing is more interactive than just reading it. So here you go. Cartilage in cells, the cells are chondrocytes. In lacunae, we're going across. The bones are osteocytes in lacunae. Vascularity, cartilage is avascular. It has no blood vessels. Just like the epithelia are avascular, the cartilage is avascular. Bone is highly vascular, just like the connective tissues are vascular, except for cartilage. Cartilage is a connective tissue. CTs proper are vascular. Okay, so the covering of cartilage is perichondrium. The covering on bone is periosteum. The strength of cartilage, it has limited strength. It bends, but it's hard to break. It can be broken, but it's hard to break. And then the bone is strong until it snaps. So it resists compression. And what does that mean? It resists compression. If I push on this table, is it going to crumple or is it going to resist compression? Right? It's going to resist compression. What about my Noteset? Is it going to resist compression? No, it's going to crumple. It's got like zero resist. Okay? So it's going to crumple because it does not resist compression. I could crush it, but then I'd have to print and fill out a new set. So, and oxygen needs in cartilage are low, which is probably good because it has no blood supply. And oxygen needs in bone are high. The nutrients in the cartilage diffuse through the matrix, and the nutrients in bone diffuse. All right, I hear you. 20 minutes. I got you. Diffuse through the canaliculi, so better diffusion. Repair in cartilage is not so much, and bone repair is extensive. So, you know that thing about how they say you're taller in the morning when you wake up? Yeah, that one's true. So the fibrocartilage of your intervertebral discs, here, during the day as you are upright, you slowly smush the fluids out of that fibrocartilage. And then at night, providing that you lay down and that you sleep for at least, I made it 2. You sleep for, second thing, you sleep for 4 hours. Third thing, okay, so you sleep for 4 hours. And laying down, okay, if you're sitting upright in a chair, it does not work. So if you're laying down for at least 4 hours, then those intervertebral joints, which I about pointed to the screen, which you can't see, these fibrocartilage of this intervertebral disc, overnight, if you're laying down and asleep for at least 4 hours, it absorbs water and it absorbs nutrients with the water. And so they do all a little bit swell. So you are actually a little taller first thing in the morning, assuming you were laying down and not sleeping in a chair and that you slept for at least 4 hours. Then you are actually taller in the morning than you are at night. So some of these things are true. How far did we get? Did we get that? We'll do that next. Okay, so this has been ANP1 Lecture Test 2 Video 6. We did page 10 and about half of page 11, and we did cartilage and bone. And I'm writing it down so that I can put it in the description once I get this to load to YouTube. So thank you as always for tuning in. It's always so nice to virtually see you here. I'm glad you're still here and checking in, and make sure you're doing all of your assignments. And where's my escape button? Here it is. The education must go on. Dr. J out.